covering the basic building blocks of trigonometry, and we will also use Pythagoras, which is closely related to trigonometry later on too. Alright, let's look at a triangle here. Now we're given a triangle, and it could be upside down, doesn't have to be like this in any kind of direction, but it definitely has a right angle in here. Alright, let's just look at another one. See, it could be upside down like that. Still got a right angle somewhere in there. It's a 90-degree angle, and also this one here could be on its side or whatever as well. So it's got a right angle on the top there. Alright, so we're starting with this triangle here. It has a given side of 30 centimeters and a given angle of 25 degrees, and we're trying to find this unknown side here, this long side, which is called A. We're labeling that A. Now what you do first of all is put in the labels of opposite and hypotenuse here. Now I'll just explain how you do this. First of all, you're never automatically given these labels here, opposite and hypotenuse. The reason why you need to do this is that we use a mnemonic, soc, car, toe, which I'll explain in a minute, based upon what these sides actually are. And there's one more side that's called the adjacent, which is over here, and that means it's next to the given angle. But I'll explain that a little bit later on. We don't have an adjacent in this particular case. The reason is, well, we don't write it in anyway, even if it's there, because you've got to leave the unknown side, or the blank side, completely blank. If it's blank, leave it blank. Alright, so we label the opposite side as opposite. If it's opposite the given angle. We have 25 degrees here, and opposite that 25 degrees, we write down the word opposite, or you could just write down the letter O if you want to, just to remind yourself. It's easier just to write a single letter in there. And the hypotenuse is in fact that's just a word for the longest side of this right angle triangle. This longest and slanting side is in fact the hypotenuse. Right, so we have the opposite and the hypotenuse, and short for that we have the O and the H, so you can just remember it as O and H. Now here's this mnemonic that sounds like a kind of Japanese word that you have to remember. You have to just say it over and over again 100 times until you remember it. So, ka, toa. And it goes up in a hill and then down again. S-O-H. So, ka, toa. Alright? So, ka, toa. And we need to use one of these little things, either so, ka, or toa, in order to solve it. Now, which one are you going to use? Now this is why we labelled everything in the first place. We've got our O and our H. Which one of so, ka, or toa has the O and the H in it? And we'll have a look at this one. It looks like it's so. We've got O and H. Now if you look at ka, C-A-H, it has the H, which we want, but it doesn't have the O. No, there's no O in there in ka. And then toa has an O in it, but there's no H in it. The only one that has both of the things that we need, the O for opposite and the H for hypotenuse, is so. So we're going to use so. And next step after you've found out which thing you're going to use, either so, ka, or toa, is to cover up the bit that you're trying to find. Now we want to find A. So we're going to cover up the H, which is hypotenuse. The A also is represented as the hypotenuse. It's the longest side, so we wrote H there as well with that, alongside with that A there, which we're trying to find. And because that's something we're trying to find out in an unknown letter, we're going to cover up our H, because H is associated with that unknown letter. It might be something else. You might have an unknown letter over here, for instance, and then if that A was over here and the 30 was over there, then in fact we would have to cover up the O instead. Alright, because then our unknown letter A will be associated with the O for opposite. But it's not, it's associated with the H. So we're going to cover up H in so. And so if you think of H being covered up, Now I've rewritten the SOT over here with the H covered up, or actually completely removed. Now you could put your finger over the H if you wanted to, and it would give you the same effect. Now what we're left with is simply O over S. That O stands for the 30. Right, we wrote down the O opposite there. That's 30 centimeters. So instead of O, you can write down, notice that what we've done over here, we've got 30 on the top of the fraction. That's how you enter it into the calculator, exactly like that. 30 on the top of the fraction, right where you see O over here on the top of the fraction, we're going to replace O with what O is. O is in fact 30. And then underneath that we've got an S. Now that S stands for sine, or sin for short, S-I-N. Now on your calculator you'll find a sine button, and the S stands for sine, and if you hit that sine button on your calculator followed by the angle that is given, the angle always comes after sine. And so what we've got on your calculator, we've got 30 over sine 25. 25 degrees in fact is this, whatever's in here, this angle that was given to us. So we're using everything that is given to us. 30 centimeters, sorry, yep, 30 over sine 25. And then you hit equals on your calculator and you get 70.99 centimeters to do 2 dp. Now if you wanted to round that to 1 dp, that would actually be fine as well. In fact, what would happen though is you could take this 9 and you have to, when the second dp is 9 or whatever it is, if it's 5 or more, then if you want to get rid of that and just have 1 dp, then you'd have to raise this digit here up 1 more. In fact, raising it up 1 more, you can't, you'd have to go up to 10, right? So this in fact would be 71.0 centimeters. Don't just write down 71, by the way, just to indicate that you have in fact rounded and it's still accurate to 1 dp. You should have a 0.0 on the end there, so it would be 71.0, or you can do what I've done here, 70.99 centimeters. Alright, let's move to the next question over here. We have a different triangle. It's a right angle once again, a right angled triangle, and we have the letter B here, and let's just pretend that we haven't written those things in there. We haven't written adjacent or hypotenuse in there yet, because in your question you'll never be given, in exams or tests or whatever, you'll never be given these labels adjacent and hypotenuse. Now we'll start with hypotenuse and I'll explain what adjacent is in just a minute. Now hypotenuse is the longest side out of all 3 sides on this triangle. You'll be able to measure it and see, well, whatever, you can just see there that slanting side is the longest side. Now that always automatically gets labelled as the hypotenuse. Now adjacent is our final word that we need to label. Now remember we had another one over here, we had opposite, and sometimes you just don't need all of them, you only need 2 of them. Now that would be, this over here we would have our opposite. Now opposite is not always at the top, mind you. Don't think, oh, opposite's always going to go at the top. No, the reason why that is our opposite is not because it's at the top, although it is, but it's not because of that. It's because our 70 degrees, which is given to us, has an opposite side which is far away as possible, opposite that 70 degrees. You can, some people actually think of this as a bow and arrow. Okay, so if you put an arrow in there, and there's a little bow there, that angles thing there, and you shoot the arrow across and it goes to the opposite side. Alright, so shoot out an arrow from here, goes as far away as possible to the opposite side. Now we don't label that as opposite because it's blank, so I'm just telling you in some cases you do need to label it, and in this case we don't label and put it in. We never put anything in when there's a blank side there. So the remaining side is called the adjacent. Now adjacent actually simply means next to. You could think of someone sitting next to you and you could say, well, that person's adjacent to me. It's a fancy word. Why don't we use next to? Well, there's probably a reason, because it's two words and adjacent is just one word. We're trying to use single words here. So, I mean, silly reason you might think, but it can end up confusing if you have next to, and next is no good because it's the one that comes after. You have to say next to. Anyway, we're using adjacent, that's the reason why we use that, and it means the thing that is right next to that given angle. So it's the one that is, I mean, you could think, well, hypotenuse is next to as well, but because it's the longest side, it gets called the hypotenuse, and the other one that is next to our given angle is called the adjacent. Abbreviating these, you could just write down A and H. So we have A and H here, and we go over here to our SO, KA, TOA once again. Now which one of these, either SO, KA or TOA, has our A for adjacent and our H? Well, we've got KA, C-A-H. Alright, and then how do we put this into the calculator? Well, you've got to cover up the thing once again that you're trying to find. We're trying to find our B. Now our B has the adjacent associated. It's called, our B is adjacent, alright? So because got that B there, we've got the adjacent there, so we're going to cover up the adjacent because that's something that we're trying to find. Our B, which is adjacent, is the thing that we're trying to find. So we cover up our A here, which has our unknown letter B, alright, associated with it. We cover up that A, and then we're left with everything else that's at the bottom. Now I've written it over here, C times H. Always multiply the things that are at the bottom here. And mind you, these are actually often called what we call magic triangles. If you put a triangle over the top here, you may have seen it in physics. Sometimes they have V equals D over T, or A equals V over T, and they have a magic triangle in order to try and, so you may have seen it elsewhere in order to try and find the unknown things, what the unknown values are and all of that. And so the same method of covering up. But we're using it for trigonometry and maths at the moment. We've covered up the A and we've got the C times the H. Now C in fact can be found on your calculator as cos. C stands for cos. It's a three-letter word on your calculator. You'll be able to find it there next to the sign, and all you have to do is press cos of the angle that is given, which is 70. Make sure you've got closed bracket afterwards, because if you don't do that you'll get it. It will come out wrong. Okay, it will include the 45 inside the brackets automatically often if you hit equals. So close the brackets, because that finishes off our cos of just the angle, and then we multiply that times the H. So C, which is cos of the angle, times our H, which is 45 here, 45 meters, so just 45, and then you'll end up with 15.4. Just check on your calculator and see if it happens. And that's to 1 dp, mind you. I've only taken 1 dp. You could take 2 dp's if you want. 3 dp is far too picky, and nobody really cares about 3 dp. It's not any use. Would you care about your height? Okay, I'm 180.568 centimeters. Well, it's been too accurate. Come on, that's just ridiculous. Even but we do want to keep things reasonably accurate. It would be to the nearest millimeter. I could be 180.1 to the nearest millimeter. Sometimes it's a bit picky too, but we do in maths, we do actually expect at least 1 dp. We don't want to round things off to the nearest centimeter like that kind of thing, or nearest meter or whatever. You've got to take a little bit more accuracy there. So either 1 dp or 2 dp is sufficient and fine. Always stick to either one or the other. 1 or 2. Take your pick. Now, next bit over here, next triangle. Again, we've got a right angled triangle, and we're going to given angle here, and right next to that given angle we've got our adjacent. That's not our hypotenuse because it's not the longest side. Now the longest side is here. It's a little bit unclear now which one is our hypotenuse. Well, here's another thing you could think of: a bow and arrow, right? Bow and arrow coming from the right angle. You shoot an arrow from the right angle and it shoots itself across to the hypotenuse. Okay, and the adjacent is the other one that's close to the 35 degrees. You can also shoot a bow and arrow from the 35 degrees that has been given, and that given angle will always have the arrow will go across to the opposite side, one that you label opposite. So opposite is the opposite of the given angle, 35 degrees. Hypotenuse is the opposite of the right angle. Shoot an arrow from the right angle, you get the hypotenuse. We're not going to label the hypotenuse because it's not given to us, and it's also not an unknown letter that we're trying to find at the moment. We're just trying to find the unknown letter here, and we're given this side over here, so we label both of those. The unknown letter we're trying to find and the given number that we're going to find. Those two things are labelled, and they're labelled in this case as adjacent, or A and O. Which one has A and O in it? Is it So, Ka, or Toa? And we can have a look and see. It's got T-O-A. Toa is the only one that has the O and the A in it. We've had So has the O but not an A. Ka is an A but not an O. Toa is just right. It has the O and the A, the very things that we're dealing with here, the O and the A. Alright, now we need to cover up our unknown letter. So C is our unknown letter, and that is represented by our adjacent, or A. So we cover up our A. And if we bring it over here, we can see we've got T, O, and then A is covered up or completely removed to make it easier for you to see. So we just have O over T. T on your calculator is just represents tan on your calculator. So sine, cos, and tan, and the S stands for sine, the C stands for cos, the T stands for tan. They're always in that order on your calculator, and the final one will be tan right there, easy to find there. And we start by writing out, well, we've got this O that's on the top of the fraction because we're looking at the O and the T if we're covering up the A. Alright, so we just need the O. Now the O is our opposite, that's a 42. So instead of O we write down 42. And instead of T we write down tan, followed by the angle, 35 degrees. And you don't need to write in the degrees symbol, but if you do that on your calculator you should end up with 59.98. Mind you, if you're doing this and you're finding that you get something different, well, just check your settings on your calculator, because there is another settings called, it's like a different unit called radians. You know how you have meters and you have feet and you have we don't use those anymore, but you have other things other than centimeters. You might have whatever, millimeters, whatever. Okay, so in the same way, there's another unit that you use in year 12 called radians, and you don't want your calculator set up to deal with radians. It's actually going to give you the wrong answer if you write in 35 and your calculator interprets that as radians. You have to have it set up as degrees, and the way of checking that, of course, is just try to write out 42 over tan 35, and you should end up with 59.98. If you do not, then your calculator needs to be somehow changed. You need to press a few buttons in the settings, have a look up your manual and figure out how to change it into degrees mode. Okay, you could take 1 dp. What would 1 dp be here? If I took this 8 and I wanted to then round this 9 up one more, I'd actually get 60. And don't just say 60, say 60.0 to specify very clearly 1 dp, 60.0 to 1 dp, or 59.98 to 2 dp. we've got 9, 9 like that. Nines, that means when you round up a little tiny little bit there, all of these figures end up changing. It just, just so happens like that because it's so close to 60. 59.99 is just a fraction away from 60, isn't it? So we go up a tiny fraction more. The next step is 60, 60.0. Okay, that would be to 1dp. Always take 1dp or 2dp. Now next one over here, finding an angle from two sides. Slightly different here. In every other case, so far we've had a given angle, 35 in that case here, and a given side, 42. While over here, and that was always the case back there, given angle and side, even way back. Alright, but now what we've got is something slightly different. We've got we're given two sides, so 70 meters and 60 meters, and our unknown is in fact in the very middle of a triangle. So when that happens, we've got an angle, we're actually doing the reverse of using the angle. We're trying to find the angle. When you're trying to find out the angle, we have to use inverse sine or inverse cos or inverse tan. First of all, what we do, of course, is label everything to find out whether we're going to use inverse sine, inverse cos, or inverse tan. We're going to have to just label everything first. So the 60 is in fact opposite the letter that's in the inside there. Now that's, I know it's not given to us, it's not 20, 30, or we don't know what it is yet, but even though, because it's relevant, it's a relevant angle that we're trying to find, the opposite is in fact the opposite of that relevant angle, the one that's relevant to us. Over here it's blank. We're not going to look for the opposite of this blank angle over here, even though we could figure it out later on perhaps, but we don't need to. It's not relevant right now, so we only look at this is relevant here, our D, trying to find out what it is, and so the opposite of that D, we've got 60 meters here, and we call that our O for opposite, and adjacent to that D we have 70 meters because our hypotenuse is over here. Obviously an arrow going from the right angle shoots over to the hypotenuse, and the adjacent is right next to the angle, or the unknown angle in this case. And if you shot an arrow from this angle here across to the other side, it goes to the opposite. Alright, so those are the three different ways of labeling everything. We don't label the hypotenuse, obviously. It's blank. In this case, we just have O and A. And which one of these, so, ka, or toa, have the O and the A in it? So again, it's toa, O and A, opposite and adjacent, is what's been given to us. And what will we cover up once again? Well, we're not going to cover up our opposite because that's given to us. We're not going to cover up our A because that's given to us as well. The unknown is in fact the T. Well, we didn't call it the T, but remember I was saying before that the angle is always associated with sine, cos and tan. It's always tan of the angle, or cos of the angle, 70 degrees in that case there. And we had sine of the angle. Well, sine, cos and tan are very closely related to the angle. So if we're going to cover up the angle, cover up our D here, then we will cover up the tan as well, which is associated with the angle. So we'll cover up the T, and we're left with just O and A, O divided by A. Alright, so we've got here O is our opposite, which is 60, over A, which is our adjacent, 70. So 60 over 70, and you take inverse tan, because we're doing the opposite operation. To find an angle, you use inverse. Alright, opposite of what we're doing so far up until now. We're using straightforward sine, cos and tan up until now, because the angle was given, and when you're trying to find the reverse of that is trying to find out what the angle is, do the opposite operation of inverse tan. Don't write down a -1 on your calculator, that will mess everything up. To get this -1, you need to press Shift Tan on your calculator. Shift Tan. So all you have to hit is Shift Tan 60 divided by 70, and then close bracket, and then equals, and you should get 40.6 degrees if you're going to take 1 dp. Again, you could take 2 dp if you wanted to. Alright, So you just got to remember, even though there's nothing here to indicate the tan symbol, we know that we're still going to use tan because t was there, even though we're covering it up. We do need to use it still, so it's inverse tan to try and find it out though. Alright, so if you're trying to find an angle, use inverse, either inverse, tan, sine or cos. In this verse it was tan because we had O over O and A, which gives us tan negative inverse tan from the toa, the O and the A. Alright, next one. This is Pythagoras. Easiest way to remember Pythagoras is simply the square root of the other two sides that have been given, and you've just got to square them and use plus in the middle. Okay, so we were given a side and another side, and we're trying to find another side. So it's all about sides. When you're looking at even the unknown as a side, everything's side, side, side. Well, side, 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 nothing in the middle that's relevant, no unknown letter or whatever. They're anything relevant except for this right angle, of course, which is no letter or number on it. But it's all blank in the middle. And you're just looking at side and an unknown on the side as well. Use Pythagoras, use a square root of the two sides squared with a plus in the middle. Now it doesn't matter which way around. If you had 30 squared plus 50 squared or 50 squared plus 30 squared, you could try both of them if you wanted to and then put square root over it, and you would end up with exactly the same answer, 58.3 centimeters. And the reason why we use plus here, mind you, is because we're trying to find a longer side. There is a case I'll just explain in a minute where sometimes we use minus. Well, we use plus for a longer side, and we use minus for what we've got over here, a minus for a short or a medium. Finding a short or a medium side, we use minus. So it's the same process as what we used for plus. You take the square root of the two other sides squared, so 80 squared minus 50 squared. Now, you cannot have a square root of a negative number, and in fact in measurement when you're trying to find sides and that, does a negative number actually make sense? Hence you cannot go short side or medium side minus very long side. You know, if I had 2 minus 5 for our long side, if 5 was our long side, then you get a negative number, wouldn't you? We don't want negative numbers in this, so we've started with our long side, and then we're going to subtract the other side that's given. So start with a long side and subtract the other side we're given. Square them as well. Enter this into your calculator. If you've got a natural display calculator, it makes it a lot easier. One that has natural display written on the top of it, and Casio FX series has that. I would recommend the Casio FX 115 ES, Casio FX 115 ES. Hopefully it will be out on the warehouse stationery very shortly, but they don't have them in stock at the moment. I had to get mine for $50 from Trade Me, brand new. The reason is that that's got a whole lot of extra features that the ones that you get in the warehouse stationery do not have, and it's only a few extra dollars. And it will last you until year 13 with all of those extra features. But if you don't get that version, you get another natural display calculator, another FX calculator from Casio, and that will still do you fine for trigonometry and Pythagoras at year 10 or 11. But once you get to year 13, you'd have to be looking at getting a new calculator if you don't have the Casio FX 115 ES calculator. So that's my recommendation at the moment. However, we're talking about solving this, and with any natural display calculator, you can enter this in exactly as it appears here with a square root, and you won't make a mistake if you enter it exactly as it appears here, of 80 squared minus 50 squared, and just hit the equal sign. You can end up with your answer there. Alright, so we're now going to look at something a little bit more complicated. Trigonometry, finding two sides from an angle on a side. Alright, so sometimes you get questions like this. and what you have to do is just ignore the little bit that you're not going to deal with. So we're going to just look at our G side first and just pretend that you haven't seen that that's opposite and that's adjacent or whatever, and none of these labels are in here to begin with. So we're going to get rid of this. So and we're actually going to not only get rid of the adjacent, we're going to get rid of that I. We don't even want the I. Cover it up. Just think that that I is not there, because we're not going to use it. It's not a given side. There's no number there for us to use, and we're not going to try and find out what I is. Not at the moment anyway. The thing that we need to find out at the moment is in fact our G. So we're focusing, narrowing, and centering in on our G. The G becomes relevant, and that side gets labelled as opposite because it's opposite the 74. And this side over here remains completely blank, so just imagine that it's completely blank. Our other relevant side is our hypotenuse, which is 4. Longest side is 4. And so the two relevant sides are our O, which has our G that we want to find out, and also our hypotenuse, which is our given side 4, and we've got the 74 degrees as well. That's relevant to us. Now what we've got to look for something that has O and H in it. There's that one there is irrelevant. We're pretending it's blank. It's not relevant at the moment. It's not a given side. Well, it's not a side that we're trying to find out, and it's not a given side. Okay, so O and H, SO. Okay, so we're finding SO immediately. If you cover up the thing that we're trying to find, which is our G, and that's our opposite as well, then you cover up O, and then you're left with just S times H, and sine is always followed. S stands for sine, and that's always followed by our angle. So sine of 74 degrees, close bracket, times 4, which is our H, S times H, and H is 4 times 4, equals 3.8 meters to 1 dp. Alright, now we've done half of the question. Now we're trying to find the other missing side here, which is in fact our adjacent I. Now let's look at I here. We can label that, if we're trying to find out I, then we can now label it as adjacent, and that becomes relevant now. It's relevant. It was irrelevant when we're trying to figure out G, but now it becomes relevant. We've got I, which is our adjacent, and G is now no longer relevant. It's no longer a relevant side that we need to figure out. The most important things here now, when we're trying to find out what I is, are in fact the I, which is adjacent to 74 degrees, and our 4 meters, which is our hypotenuse. It's a given side, which is always relevant there because it's a given information. So we've got adjacent and H, A and H. Now the only one of these here, so, ka, or toa, is ka. We've got C, A, H. And once again, if I cover up our letter, the thing that represents our letter we're trying to find. So we're trying to find our I, and we know that A represents that. We're going to cover up our A and ka. Cover up A, and then we're left with C times H at the bottom when we cover up our A. Alright, so we've got cos, which C stands for cos. That'll be next to your sign on the calculator, so you press cos on your calculator. 74 close bracket times 4 equals 1.1 meters to 1 dp. Mind you, you should always check and see whether this actually makes sense or not. Okay, let's just check whether these things actually make sense. Well, because if you got a really wildly different, if you had 38 meters, or something weird, really weird like that. Now, is that realistic? Where if we had 38, well, 4 meters, our longest side is 4 meters. We're going to look for something slightly less, and this side actually does look like slightly less than 4, doesn't it? So we're looking for something that's 3.8. That's going to be correct. Okay, so you can just check, just do a quick check and see whether it actually looks like it is correct. Use a bit of common sense to check our answers, see if they make sense, whether they really do look like they're realistic. And if they're not, then you're going to have to look back and see if you've made a mistake or not. Once again, also 1.1 is actually quite realistic. Look at that side there. Okay, so that side is a lot shorter than our 4. Yeah, it's not drawn perfectly to scale, and people do that on purpose in the exams because they don't want you to measure it and get the answer. If you measured it, you'd be able to figure out the answer, wouldn't you? So they purposely draw it slightly off scale, but it's usually reasonably accurate. It's a little bit off, so it's drawn as a little bit longer than what it should be probably here, but more or less, give or take a certain amount. You know, that could be a third or a quarter of 4, which is 1.1, right? So, you know, that's reasonable. 1.1 meters could be accurate. So we're going to say that that's our answer. It certainly looks like it's correct, and we've entered it in. It's correct. Just believe me, that's correct. Just always check though that it makes a bit of sense there. Alright, our another one here, we could be finding, for instance, 2 other things. We could be finding a side and an angle if we're given 2 sides. Now, if you were given, let's say you were given 30 here, 30 centimeters on that short side there, and then 55 on the long side, hypotenuse, and you're trying to find out. Let's start with J, letter J. Now that's a medium side. It's not the longest, and it's not the shortest. But if you're not trying to find the longest, then you have to use minus. Now, why am I using square root and Pythagoras in the first place? You might think, well, there's an angle in here. Why are we using square root when there's something in the middle? I thought we're meant to be using trigonometry and there's something in the middle. Well, that k, yes, it is in the middle. Yes, it is, but it's not relevant to us. The only things that are relevant are the given things, 55, which is given to us, and 30, which is given to us, and the thing that we're trying to find out. Now, at the moment, yes, we're trying to find out k later on, but at the moment, we're only trying to find out what j is. So k becomes temporarily, or just for a short time, irrelevant. We don't need to find out what k is. It's not any information that we can use at the moment either, and it's something that we're not even trying to find out at the moment. So j is the important thing, and we can just ignore k in the middle as if there's nothing in the middle there, and we're just left with these things on the outside that are relevant. When the only things that are relevant are on the outside of a triangle, on the sides here, then you have to use square root. Square root of the other 2 sides. Start with the longest side, because if you subtract something bigger, you're going to get a negative number, and it won't work. You can't have a negative thing. Well, for one, you can't have a negative something. You can't take the square root of a negative number. Try that. Try -1, take the square root of -1. It won't work. Try it on your calculator, you'll get an error. And even if you could, and if you ended up with a negative answer, well, you know, you can't have a negative answer anyway, because how can you get a negative side? That's impossible. Alright, so you just realistically, you've got to start with the longest side and subtract something that is shorter. Obviously your longest side is that one there, just subtract the other one, minus, and then subtraction is common sense too, because you add to get something bigger, you subtract to get something smaller. Now this is a medium side, it is in fact smaller than the longest side here, so we're going to subtract 55 squared minus 30 squared, take the square root, and there's your answer, 46.1 centimeters. Now we're going to look at the other thing that we need to find out. We've found out our j side. Now we can ignore that j and pretend that it's not there. It's not a given angle, it's nothing that's been already given to us or anything like that. Remove it completely, pretend that it's not there, it's not relevant, we're not going to use it in our calculations at all. So if we're not going to use it in our calculation, and all we have to do is just leave that one blank, just pretend you haven't written opposite in there, cover it up if you have to, and we're just left with hypotenuse, the longest side, and adjacent, the angle that is adjacent to the angle. Now this is an unknown angle, so we will use the inverse sine, inverse cos, or inverse tan. So which one are we going to use? We've got A for adjacent and H for hypotenuse, because the opposite is irrelevant to us. J is not something we're trying to find, or it's not given to us. So we just leave it on blank. We've just got A and H. Which one is A and H? We've got Ka, A and H. And with that we have, we've got to cover up our angle, because that's the thing we're trying to find. And associated with that angle is either the sine, cos or tan, because we always write in when we hit something into the calculator, like have a look over here again. So we've hit sine followed by the angle, cos followed by the angle. The angle is always associated with sine, cos or tan. Always comes after sine, cos or tan. You put in the angle after that. So we're going to cover up our angle, and so we cover up the sine, cos and tan, which goes with the angle. So in this case here we cover up the C. Alright, so when you do that you're left with just simply A over H. Alright, so this is what we've got. Make sure you write in the cos to -1 when you're trying to find an angle. Don't type in -1. Do not do that, you'll get it completely wrong if you do that. Press shift cos on your calculator and it will come up with a -1 on there. Okay, especially if you've got one of the modern natural display calculators. By the way, just don't go for the old ones. You know, if you get a $10 calculator that's just old-fashioned, it's just not worth it. You're going to make mistakes. Are exams important to you? You pay $20 more. You can get a natural display calculator. It might not be the one that I'm recommending, but if it at least has natural display written on it, then it could be $30, $35, and it's well worth it. You're not going to make anywhere near as many mistakes, and you can just enter in everything exactly as it appears on paper. Okay, so shift cos will give you cos -1 coming out on your calculator, and it will come up with a bracket, most probably 2 for you right there. All you have to do is enter in 30 over, put the fraction symbol into your calculator. There'll be 2 boxes. There'll be a symbol with a box over a box, one little key that has a box and a box, and a line between those 2 boxes is a key V on your calculator. Press that key and enter in 30 and move down with the arrow keys to write down 55. Those are your 2 values there. You've got A, which is 30, so A over H, so 30 goes on the top, H goes on the bottom, which is 55, right? H is our 55 there. And then close bracket, hit equals, and you end up with your degrees there, your 56.9 degrees. And once again, have a look, is that roughly, right angle would be all the way a square, sort of. This is a little bit more than halfway around to 90, it's about 56, 45 is halfway, and it's a bit more than halfway. Just have a look and see whether it actually makes sense once again, just to check, because if you got 10, well, that angle is much more than 10, right? So if you got like 87, well, it's not quite near a right angle yet. It'd be too much. So just check to see where it actually makes sense, and then you can go back and see whether you hit the wrong thing. Alright, because you could have done, for instance, tan and sine just by mistake, and you could see straight away, well, this is out, this is wrong. You could self-correct yourself. You could say, oh, I've got 5 degrees as my answer. There's no way that could be 5 degrees. This one here, over here, is going to be quite small. But not that angle. That angle's a bit bigger. It's not, that's not 5 or 10 or even 20 degrees. It's more than that. You look at a protractor and see that's going to be more than 20 degrees. Now remember, they're not drawn perfectly accurate when the examiner or whoever writes the exam. They don't do it accurately on purpose, but they're going to be more or less accurate. So you look and see whether that really does look like 56.9, and you can self-correct yourself and fix up any error that you've made is likely to be something that is probably well off, and you have a look and see whether it does indeed look accurate or not. If it doesn't, then go back and change it, see whether you've made a mistake or not. You might have used sine, for instance, instead of cos, and then you try it out and it does look right. So that's correct to 1 dp. Right, and that ends our discussion here.